In our hyper-connected world, a rumor can circle the globe in minutes. In the summer of 2025, one such rumor exploded. NASA had found life, not on Mars but on Proxima Centauri B, a planet orbiting the star next door. Headlines blazed across every screen, alien life discovered just 4.2 light-years away. For a moment, humanity believed we were no longer alone. The idea of alien cities and strange forests under a red sun captured imaginations everywhere. But as excitement soared, scientists urged caution. NASA stayed silent. The gap between viral headlines and scientific reality grew. Where did the rumor start? Was it a misunderstood signal, or just wishful thinking amplified online? The truth, as always, was more complex and more interesting. To understand what really happened, we need to look at Proxima B, the science, and the search for life itself. Let's meet our cosmic neighbor, Proxima Centauri, the closest star to our sun, shining faintly in the southern sky. Though it's invisible to the naked eye, this tiny red dwarf holds a special place in our search for life beyond Earth. Orbiting this dim star is Proxima B, a planet discovered in 2016 that immediately captured the imagination of astronomers worldwide. Proxima B is a rocky world, just a bit more massive than Earth, and it orbits its star at a distance so close that a year there lasts only days. What makes Proxima B truly intriguing is its location in the so-called habitable zone, the region around a star where temperatures might allow liquid water to exist on a planet's surface. This is the first step in the long checklist for life as we know it. Proxima B completes a full orbit in just 11.2 Earth days, circling its faint red sun at a distance of only 4.5 million miles. That's about 20 times closer than Earth is to our sun, making its year incredibly short. This close proximity means Proxima B receives enough warmth for water to potentially exist, but it also faces intense radiation and powerful stellar flares from its parent star, conditions that could threaten any chance for life. Unlike most exoplanets, which are light-years farther away, Proxima B is close enough, just over 4 light-years, for our most advanced telescopes to study in detail. This makes it a prime candidate for future exploration. For the first time, we have a real opportunity to examine a potentially habitable world up close, to search for signs of water, an atmosphere, or even life itself. Does Proxima B have an atmosphere to shield it from radiation? Are there clouds, oceans, or even the faintest hints of biology? These mysteries fuel our curiosity and drive our scientific ambitions. Astronomers around the world are poring over data, developing new instruments, and collaborating across continents to unlock Proxima B's secrets. Every discovery brings us closer to answering the age-old question, are we alone? Proxima B isn't just a distant dream, it's a tangible, reachable target, sitting at the edge of our solar neighborhood waiting to be explored. The stage is set for a new era of discovery. With each technological leap, we get closer to sending probes, or even one-day people, to worlds like Proxima B. But this proximity is a double-edged sword. It offers the promise of discovery, but also the peril of harsh cosmic conditions that could make life difficult or even impossible. As we set our sights on Proxima B, we must prepare for both the wonders and the challenges that await us in this new frontier. To truly study Proxima B, humanity needs more than just powerful telescopes. We need instruments that can peer deeper, further, and with more precision than ever before. Enter the James Webb Space Telescope, or JWST, a technological marvel that represents the cutting edge of our quest to understand the cosmos. Launched in 2021 after decades of planning and international collaboration, JWST is designed to see the universe in infrared light. This unique ability allows it to look through thick clouds of cosmic dust that would block ordinary telescopes, revealing hidden stars, galaxies, and even the faintest exoplanets. One of JWST's most exciting missions is to analyze the atmospheres of distant exoplanets, including the intriguing Proxima B. Using a technique called transit spectroscopy, JWST can break down the starlight that passes through an exoplanet's atmosphere, searching for the chemical fingerprints of life. When Proxima B crosses in front of its parent star, even the tiniest fraction of starlight that filters through any atmosphere can be captured by JWST's sensitive instruments. This light carries clues about the planet's composition, temperature, and potential habitability. Scientists then meticulously analyze this data, searching for biosignatures, gases like oxygen, methane, or water vapor that could hint at biological processes. The presence of these molecules in the right proportions might suggest that life, as we know it, could exist on Proxima B. Some researchers even dream of detecting artificial lights or other technological signatures on the planet's night side, a tantalizing possibility that would point to intelligent life. While this remains a distant hope, it fuels the imagination of scientists and the public alike. Yet, the challenge is immense. Proxima B is a small rocky world orbiting a red dwarf star that is both noisy and highly active. The signals we seek are incredibly faint, often drowned out by the star's flares and magnetic storms, making the search for life even more difficult. As of August 2025, despite JWST's unprecedented capabilities, no confirmed atmosphere or definitive signs of life have been detected on Proxima B. The data is complex, and every potential signal must be scrutinized and verified. The search is painstakingly slow and methodical, requiring patience and persistence. But in many ways, it has only just begun. Each new observation adds another piece to the puzzle, bringing us closer to understanding this distant world. Every bit of data, every discovery, no matter how small, brings us one step closer to the truth about Proxima B and the possibility of life beyond Earth. While rumors and speculation often outpace the slow march of science, the real work continues behind the scenes, with teams of scientists dedicated to unraveling the mysteries of our universe. The universe keeps its secrets well, but with tools like JWST and the determination of countless researchers, we are closer than ever to unlocking them. Proxima B is no Earth twin. Its close orbit likely means tidal locking, one side scorched in endless day, the other frozen in perpetual night. The only potentially habitable region is the narrow twilight zone between extremes. For life to survive, Proxima B would need a thick atmosphere to circulate heat and protect against wild temperature swings. But the existence of such an atmosphere is uncertain. Without it, the planet faces violent winds and deadly cold. Life here would be nothing like Earth's, maybe underground or deep beneath ice shielded from the surface. Even in the habitable zone, conditions are brutal. Habitable doesn't mean hospitable. Proxima B is a world of extremes, not comfort. The biggest threat to life on Proxima B is its own star. Proxima Centauri is a volatile red dwarf, unleashing powerful flares and radiation. In 2017, a superflare blasted the system with X-rays, hundreds of times stronger than anything Earth receives. Such events can strip away atmospheres, boil oceans, and sterilize planets. Only a strong magnetic field could offer protection, but we don't know if Proxima B has one. The very star that could warm the planet may also destroy its habitability. Some models suggest survival is possible with a thick atmosphere or deep oceans. Others are less optimistic. Until we can measure Proxima B's atmosphere, the question remains open. The star's fury is the ultimate wild card. JWST is powerful, but it wasn't built to find Earth-like planets. To truly search for life, we need the Habitable Worlds Observatory, NASA's next flagship mission, planned for the 2040s. HWO will directly image Earth-sized planets, using advanced technology to block starlight and reveal faint worlds. It will analyze dozens of atmospheres for biosignatures, oxygen, methane, water vapor. This mission could finally answer the question, are we alone? Planning is underway, but it's a long-term, multi-generational effort. The dream of HWO is the dream of finding life beyond Earth. So where did the 2025 rumors come from? Not from NASA, but from a mix of excitement, misinterpretation, and viral online chatter. Every new JWST dataset is scrutinized, and even ambiguous hints can spark wild speculation. This isn't the first time. Back in 2019, a mysterious radio signal from Proxima Centauri turned out to be earthly interference. The public now associates Proxima with alien possibilities. A leaked, unverified data point can quickly become proof in the echo chamber of social media. Official statements remain clear. As of August 2025, there's no evidence for life on Proxima B. The rumors were just that, rumors. This episode is a reminder: science is slow, careful, and rigorous. The search for life is a marathon, not a sprint. Why do rumors about distant planets and the possibility of life beyond Earth captivate us so deeply? What is it about the unknown that draws our eyes upward, night after night, generation after generation? The question, are we alone, is more than just curiosity. It's a longing that sits at the core of what it means to be human. It's a question that echoes through our stories, our art, and our dreams. For thousands of years our ancestors have looked to the stars, searching for meaning, for signs, for connection. The night sky has always been a canvas for our hopes and our questions, a place where we project our deepest wonderings. Today the search for life is both a scientific pursuit and an existential journey. It challenges us to rethink our place in the universe, to confront the possibility that we are not the only sentient beings to ever gaze at the stars. Ambitious missions like the James Webb Space Telescope and the upcoming Habitable Worlds Observatory push the boundaries of technology and knowledge, allowing us to peer deeper into the cosmos than ever before. In searching for signs of life elsewhere, we also learn more about our own planet, its delicate balance, its unique biosphere, and the factors that make Earth so precious and rare. Imagine the moment we discover even the simplest life beyond Earth. That revelation would unite humanity, spark new questions, and forever change how we see ourselves and our place in the cosmos. It would remind us that we are all Earthlings, sharing a fragile world, and that we are part of a much larger cosmic story, one that is still unfolding. This quest fills us with hope and wonder, inspiring new generations to dream, to explore, and to ask big questions about life and the universe. We search because we are curious, because the universe is vast and mysterious, and because we long to know if we have company among the stars. Our curiosity is boundless, and our desire to connect is universal. The journey itself, full of discovery, challenge, and wonder, is as important as the answer we seek. Every step forward brings us closer to understanding not just the cosmos but ourselves, and so, with hope, curiosity, and a sense of shared destiny, we keep looking, reaching out into the unknown, searching for our place in the universe. As of August 2025, we know Proxima B is a rocky planet in the habitable zone of our nearest star. We know it faces harsh conditions, tidal locking, radiation, and uncertainty about its atmosphere. JWST continues to gather data, refining our models and narrowing the possibilities. A definitive answer on life is unlikely soon, but even finding an atmosphere would be a breakthrough. The next generation, HWO, will expand the search to dozens of worlds. New telescopes and missions will keep filling in the cosmic map. The search for life is a long, patient journey. The recent rumors show our hunger for discovery. The universe keeps its secrets, but we persist. The truth is out there, waiting for us to find it.